to Module 1, Lesson 18. I'm Mrs. Gradney, and today we'll be solving multi-step word problems, and we'll be thinking about the reasonableness of our answers. So let's go. Throughout our lesson today, we'll be using a problem set, so make sure you have that in front of you. And we'll also be using the RDW process, read, draw, write, to help us make sense of the problems. Our directions tell us to draw a tape diagram to represent each problem, use numbers to solve, and write your answer as a statement. So basically, our directions are telling us to use the RDW process. Let's start with problem 1, and we'll read the whole problem together. Remember, while we're reading, to be picturing in your mind what's happening in the story. Ready? Read. In 1 year, the factory used 11,650 meters of cotton, 4,950 fewer meters of silk than cotton, and 3,500 fewer meters of wool than silk. How many meters in all were used of the three fabrics? Now, before I send you off to draw your tape diagram, let's take a moment to think about what's happening in the story. What do we know, and what are we looking for? Pause the video to talk out your thinking. You may have said one thing that we know is how many meters of cotton were used. They told us that. Now, they also used silk, but we don't know how much silk was used. But we do have a comparison of the silk to the cotton. Then there's the wool. They also used wool fabric. We don't know how much wool was used, but again, we have a comparison for the wool, but this time they're comparing the wool to the silk. And what we're looking for is how many meters of the three fabrics were used in all. Now, pause the video to draw your tape diagram to represent the story. If you get stuck, remember you can go back and reread it a chunk at a time and just ask yourself what you can draw for each little chunk. When you're finished drawing your tape diagram, come back and we'll compare. Welcome back. Here's the tape diagram I drew. Is it similar to what you drew? Now, some of you may have been thinking while you were drawing, wait, is it okay to have 3 tapes in our tape diagram? We've only had 2 tapes in our tape diagram so far. Well, the answer is yes. We can have as many tapes in our tape diagram as we need for the things that we're comparing in our word problems. Now, what does our tape diagram tell us about how we might solve? Pause the video to talk out your thinking. You may have noticed that in order to find out the total of all 3 fabrics, we have some other things that we need to find out first. We don't yet know how much silk was used or how much wool was used. So we'll need to find out those amounts before we can find out the total of all 3. Pause the video now to solve the problem using numbers and to write an answer statement to answer the question. Welcome back. Hopefully you found that 21,550 meters of fabric was used. If you didn't, remember to always compare your work to the work on the screen and see if you can find your mistake. Now, how did you solve the problem? Here's how I solved it. First, I subtracted 4,950 from 11,650 so that I could find the amount of silk that was used, which was 6,700 meters. Then I subtracted 3,500 from 6,700, as we can see here, so that I could find the amount of wool that was used, which was 3,200 meters. And then finally, I just added up the amounts of the 3 fabrics to get the total. Now, how can we know if 21,550 meters of fabric is a reasonable answer? Maybe you said, well, I can just round each of the amounts and then add up those estimations. So 11,650 is about 12,000, plus about 7,000 for the silk, it's 19,000, plus about 3,000 for the wool is 22,000. So that's really close to what we got, and so yes, our answer is reasonable. Okay, let's look at problem 2 now. Pause the video and read problem 2 to yourself and draw a tape diagram to model the story. Remember to pay close attention to what you're comparing each item to. And if you get stuck, remember to just go back and focus on one little chunk at a time. Ask yourself, what can I draw just to represent that one little part of the story? When you're done, come back and we'll compare our tape diagrams. Get to work. Welcome back. Here's the tape diagram I drew. How does it compare with what you drew? Now, what can we tell by looking at our tape diagram? By looking at our tape diagram, we can tell that we know the total amount of chocolate cones that were sold, and we know the total amount of cookie dough cones that were sold. We don't know the total amount of peanut butter cones that were sold or the total amount of vanilla cones that were sold. But we can tell that the peanut butter cones are being compared to the cookie dough cones. So this part of the peanut butter cones is the same as the cookie dough cones, and then there's this extra part for the peanut butter cones. And for the vanilla cones, they're being compared to the chocolate cones that were sold. And so this part of the vanilla cones is the same as the chocolate cones that were sold, and then there's this extra part. We can also tell that we're looking for the number of cones that were sold in all because of this bracket that's holding all 4 of those tapes and the question mark out to the side. So pause the video now and solve the problem using numbers and write an answer statement to answer the question. Then come back and we'll compare our work. Did you find that the shop sold a total of 46,303 ice cream cones? Here on the screen, you can see one way that you may have solved it, though this is not the only correct way to solve. Does it look similar to how you solved it? Now, let's look a little bit deeper at this solution pathway. To find the total number of vanilla cones, some of you may have found that total by adding 12,789 plus 999 using the algorithm. That makes sense, and it would totally work. But let's take a look at how the number of vanilla cones were found in this example. Here. In this example, a simplifying strategy was used. Remember, a simplifying strategy is a strategy that can help us to do mental math. So how does this simplifying strategy work? In this simplifying strategy, we know that 999 is really close to 1,000, and 1,000 is a super friendly number to do mental math with. So we could add 12,789 plus 1,000 in our heads to get 13,789. And then, since we know we added one too many, we just have to take one away to get 13,788. Now, how do we know that our answer of 46,303 ice cream cones is reasonable? There are several different ways you may have thought about knowing if your answer is reasonable or not. For example, you may have just rounded each of the numbers of cones and then added those estimations together to determine if your answer was reasonable. Another way that we could think about it would be to think about, okay, the number of chocolate cones is about 13,000 cones, and then this part of the vanilla is another 13,000, so that would be 26,000. And then the peanut butter cones, that would be about 10,000, and if I took this little part here from the vanilla and put it here with the cookie dough, that would make another about 10,000. So these two together would make 20,000. 26,000 plus 20,000 is 46,000. And that's really close to what we got. So we know our answer is reasonable. Let's move on to problem 3. In a moment, I'll ask you to pause the video and use the RDW process yourself to solve the problem. But first, let's review what you'll do. First, you'll read the problem and you'll draw a tape diagram to represent what's happening in the problem. Remember that you can go back and reread as you need to help you to draw the tape diagram. Then you'll ask yourself, what does my tape diagram tell me about how I can solve? And you'll use numbers to solve, and you'll write an answer statement to answer the question. Remember, after you finish and you write your answer statement, to go back and reflect on if your answer makes sense. Now, pause the video and do the work, and then come back and we'll discuss. Welcome back. How did you do? Did you find that 40,284 omelets were sold in June? On the screen, you can see 2 different ways that this problem could be solved, though these are not the only correct ways that you could have solved. But let's take a moment to compare these 2 solution pathways and think about why they each make sense. So pause the video to compare these 2 ways to solve and talk out loud about why each one makes sense. And then come back and we'll discuss. In the first solution pathway, they found the number of omelets that were sold each week and then added them together. So here they found how many omelets were sold in week 2, in week 3, in week 4, and then added them together. That makes sense. In the second solution pathway, they first added together 3 units of 10,345. Where can we see 3 units of 10,345 in our tape diagram? I can clearly see 2 units of 10,345, but where's that third unit coming from? Well, since we're adding 2,000 to 10,345 here and subtracting 2,000 from 10,345 here, it's like we could move this 2,000 part to here, and then we'd have another unit of 10,345. So they added those together, got 31,035. Then they found the number of omelets that were sold in week 2, and then just added those together to get the total number of omelets sold in June. Now, how do we know that our answer, 40,284 omelets, makes sense? You could think about this in a couple of different ways. One way would be just to round each week, starting with week 1 and continuing on. So in week 1, about 10,000 omelets were sold. Week 2, about 9,000. Week 3, about 12,000. And week 4, about 8,000. And together, that makes 39,000 omelets, which is really close to what we found. Great job today, friends. Today, we solved multi-step word problems, and we thought about the reasonableness of our answers. Remember to check in with your teacher, and I'll see you next time for another Eureka Math lesson. Bye!